All right, so today we're going to be talking about angles, angle bisectors, and the angle addition postulate. An angle is a set of points consisting of two different rays that have the same endpoint called the vertex. So if you look at this diagram below, it shows you the sides. So AC is a side, ray AB is also a side, and then angle A would be the vertex. All right, notice that there's also an interior versus an exterior of an angle. So if you look at this diagram shown, this right here, if it's inside of the angle, then it would be considered the interior, whereas if it's outside of the angle, then it would be considered the exterior. All right, so it says list all the possible names for the above angle. So there are several different ways that you could name that. You could either call it angle A, you could call it angle 1, you could call it angle CAB, where A is in the middle because that's where your vertex is. Or you could say BAC. You wouldn't be able to say BCA because then you would be talking about a different angle there. So A would have to be in the middle because that is the vertex that you're talking about. That's the angle that we're talking about here. So it does have to be either CAB or BAC. It doesn't matter which of those as long as the A is in the middle. Okay, for this first example, it says a lighthouse keeper measures the angles formed by the lighthouse at point M and the three boats. Name the three angles shown in the diagram. All right, so here's the first angle. So this one here is the first angle. We're going to call that angle JMK. Okay, so either I could say JMK or I could say angle KMJ. So that's the first one. Either of those is acceptable. Okay, for the second angle, I'm going to do the one on the bottom, which is this one here. I'm going to kind of erase this just to get it out of the way. All right, so for this next angle, the angle on the bottom, I'm going to call that angle KML or angle LMK. All right, so either of those would work. The last angle is the big angle, the overall angle, which is this one here. So I'm going to call that one has two names. I'm going to call it either JML or angle LMJ. Now, in this particular case, you would not be able to call this angle M, because angle M could be any of those angles. It could be any of those three angles. So you wouldn't actually be able to use angle M because it doesn't specify which angle you're talking about. Now, for this first example that I showed you with angle A, the first one that I showed you, I could use angle A because that's the only angle. That vertex is secluded, it's by itself, so you would be able to use it in that case. But for example 1, you wouldn't be able to do that because that shares many different angles. All right, so let's go ahead and look at example or practice 1. Actually, go ahead and pause this video and try it on your own, and then we'll go over it. All right, for number 1, it says write three names for the angle. So for this first one, that could either be called angle Q, or it could be called angle PQR, or it could be called angle RQP. So either of those would work. For example 2, there's actually 4 different ways you could write this, and I'm actually going to show you all 4. I know that it only says to list 3, but that's fine. So either you could call this angle 1, you could call this angle Y, you could call this angle XYZ, or you could call it angle ZYX. Either of these would be acceptable. For example 3, you could either call that angle FED, or angle DEF, or you could call it angle E, or you could call it angle, angle 2. So either of these would work. All right, let's look at this next page. So we have the 4 types of angles, which you guys probably learned in elementary. So this first one, it is below 90 degrees. So this would be considered an acute angle. The second one is exactly 90 degrees, so that is called a right angle. This next one is greater than 90 degrees but less than 180 degrees, so this is called an obtuse angle. And this last one is exactly 180 degrees, so it is called a straight angle. All right? So now let's look at example 2. It says find the measure of each angle and then classify each angle. So let's look at example A. Example A, we're asked to find the measurement of GHK. Now, I want you guys to notice where this angle starts, where like the bottom line is, or the bottom edge. The bottom edge is right here. We have to make sure that when we're reading this, we start off with a 0. So in this case, I wouldn't use the inner part of the protractor. I would use the outer part of the protractor because that's where it is at 0. So then I'm going to start on the outer part and I'm going to find where it stops at the K. Now again, I started off at the outer. I need to stay at the outer. So that's about 125 degrees. So this is 125 degrees. That is greater than 90 degrees, but less than 180 degrees, so this would be considered obtuse. All right, for this next one, I'm gonna do the same thing. So I'm asked to find JHL. So because JHL, the J starts on the right side, I'm going to need to see where that part starts at 0, and that's actually using the inner part of the protractor. So then I'm going to need to use the inner part to find my angle. So if I was to do that, I would, go up and I would see where it ends at the L, and that is at exactly 90 degrees. So 90 degrees, that is a right angle. Let's look at this next one, angle LHK. So LHK is right here, LHK. Now for this, it doesn't really matter whether you use the outer or inner as long as you're consistent. You will need to subtract to find, the total angle. So I'm going to do 90 minus 55. I'm actually using the inner portion. So I'm doing, my L is at 90 degrees, so 90 and then minus 55, and I'm going to make sure to take the absolute value of that because remember, measurements cannot be negative. And then this equals approximately 35 degrees. That is less than 90 degrees, therefore this is an acute angle. All right, now everything we just talked about has everything to do with the angle addition postulate. Last time we talked about the segment addition postulate. Angle addition postulate is the exact same thing. So an example here would be if I had an angle that looked like this, so let's say that this was S, and this was R, and the middle one was P, that's a P, and then this one is T. All right, so if I was to look at this, then I could say that measurement of angle R, SP, plus the measurement of angle P, ST, is equal to the measurement of angle RST. So it's kind of the same thing. So if you have the smaller angle plus the smaller angle, it's going to equal the overall angle. That is the angle addition postulate. That is something that you might have to use in the future when we're doing proofs, so make sure that you memorize it. All right, example 4. It says that given that the measure of angle LKN is 145 degrees, so that's LKN, that's the whole thing, 145 degrees. Find the measure of angle LKM and MKN. All right, so I'm going to use the angle addition postulate. I know that these two angles make up the larger angle. So I'm going to say 2x plus 10 plus 4x minus 3. You always want to keep it in parentheses just in case there's a minus sign and you need to distribute. That's all going to equal a total of, they told us, 145 degrees. So the first thing I need to do is solve for x and then plug it in. So I'm going to go ahead and do that. I have 6x plus 7 equals 145. I'm going to subtract the 7 on both sides. I get 6x equals 138. And then when I divide 6 by both sides, I get that x equals 23. All right? So I just found the x value. I didn't really find anything else. I need to still use that to find my two angles. So I'm going to plug that into LKM first. So angle should be angle LKM. So I'm going to do 2 times 23 plus 10 equals 56. So that's my first angle. And then for the second one, you have two options here. Either you could plug in the x, or you could just subtract 56 from 145, which would probably be the easier thing to do here. So I'm going to do that. So MKN. So in order to do that, I'm just going to do 145 minus 56 degrees. That's going to give me a total of 89 degrees. All right. Yesterday we talked about segment bisectors, and we said that segment bisectors basically cut a segment in half. It bisects a segment. Angle bisector is the same thing, except this time we're talking about angles. So an angle bisector is when a ray that divides an angle into two congruent angles. All right. So looking at this example, we have BD bisects ABC. Find the measure of angle ABD, the measure of angle CBD, and the measurement of angle ABC. I'm going to go ahead and give you guys some time to do this. Actually, go ahead and pause this video and try to do it yourself. All right, you guys should have already tried this. So first off, we know that ray BD bisects angle ABC, which means that angle ABD and angle DBC are going to be congruent, which means that their measurements are going to be the same. So I'm going to set them equal to each other, which is what I did here. So I set them equal to each other and I solved for x. I got x equals 4. Then what I did is I took 4 and I plugged it into each of these. I actually started by plugging it in to ABD, which is 8x plus 35. I plugged in the 4 and I got 67. And then instead of trying to plug that into the second one, I already know that these two are going to be the same because it tells us that BD bisects the angle, right? So if it bisects it, both of them are the same. There's no need to do all the extra work. If you know that information. So then I also know that angle BDC is also 67 degrees. If both halves are 67 degrees, then I know that my entire angle is going to be 67 plus 67, which is 134 degrees.